In this problem, we are given two strings and told to find if string A can be obtained by rotating string B by two places. So, for example, an input we'd have is string A, and we can rotate string B by two places to obtain A. So, for instance, you move the M to the front and then the A to the front. Likewise, you want to know if you could rotate it in the other direction. You have to consider both clockwise and anti-clockwise. So the way I'm approaching this problem is I'm going to rotate string A by two places, both clockwise and anti-clockwise, and see if I can achieve string B. It's the same thing, just I'm taking the reverse approach to get the desired output. So I'll start with the function definition. It's asking us to return true or false, so our return type will be bool here. And we have two inputs, string A and string B. Okay, I'm going to take care of conditions when the string is either null or of different lengths. So obviously, if A or B is null, then you can't obtain one by rotating the other. Or if the lengths do not match. Likewise, if the length of the string is less than 2, we have a special case. Because let's say the string is 2 characters. If you rotate that twice, you just get the same string. So if it's less than or equal to a length of 2 and A and B are not equivalent, then I'll be returning false. Whereas if the length is less than or equal to 2 and A is equivalent to B, then I'll be returning true. Okay, I'm going to create a few variables here. Front, back, and store A. I'll assign string A to store A. Okay, so what I'm going to do is isolate the first 2 letters of A and isolate the back 2 letters of A. I'll start with the back. And we do want them in the order in which they appear. So that's why I'm chopping off the second to last, and then now I'll chop off the last one. And I'll get the front. Now I will remove the first two characters in A. And here I'll remove the last two characters in A. Now I'm going to, so what I did here is I removed the first two characters. So I have A, Z, O, N. And what I'm going to do now is append the front two characters to the back. By combining store A plus front. Likewise, to consider the other rotation, I'll combine the back two letters plus A, which has had the last two elements removed. In this way, I've rotated string A by two places to find out if we can obtain string A by rotating string B two places. I've done something slightly different to achieve the same result. And that is the end of the function definition. So let's consider the time complexity and space complexity. Space complexity is constant, and the time complexity, so the only thing we're ever going to be doing is chopping off and appending two characters. So the number 2 does not depend on n, which means the time complexity of my algorithm is constant. That's pretty awesome. Okay, so let's run this through and double check our logic. So A or B is not null. These two strings are the same length. We move past, and considering A and B as our input. Not less than 2, not less than 2. We have these variables, and store A now has A. So I'll write out split this. I will write out the current value for store A, the current value for A, for front, and back. Okay, so store A is now A. A is obviously A. Okay, so getting to back. So the second to last letter in A, O, combined with the last letter in A, N, is assigned to back. So back is now O, N. Excuse me. Likewise, the first two letters in A are assigned to front. A is now AM. Store A, we're removing the first two characters. Store A is now Azan. A, we're removing the last two characters. A is now Amaz. Store A is store A plus front, so AZON, AM, and A is back plus A is ONAMAZ. So let's check. Is B equivalent to store A? AZONAM? Yes, it is. We don't even have to check the OR condition, and we will be returning true here. So that's exactly the output we desired.